I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation, MSDN Webcast, C# 2010 Soup to Nuts, Part 7, Classes and Objects. Now it's my pleasure to introduce today's presenter, Bill Steele, Senior Developer Evangelist for Microsoft. Bill, you now have the floor.
Thank you, Sydney, and welcome back to this seventh in our series on C# Soup to Nuts. Today we are going to be talking about classes and objects. I've talked about this before, but everything within the .NET framework is based on an object called system.object. And as a developer, we have to define those objects. And the way we define those is through a technique called classes. So we're going to take a look at both classes and objects today. We'll see how you define a class and how you can actually use it to create objects or instances of those classes. Then see how we can actually extend those to make them a little bit more useful. So let's start off with the basic of what a class is. A class is literally a blueprint for some type of an object. When we think about a house or a building, generally before that house or building is built, there was a blueprint design that told something how to construct that house or building. And that is exactly what a class is. A class is basically a model, if you will, in software that defines what an object will look like, what kinds of properties it has, and what kinds of functionality it incorporates. Now, when we talk about classes in C#, we're basically referring to some kind of an object definition that we can utilize as a basis for other functions. So a good example of that is a person class. Generally, a person has some characteristics that's shared across other types of objects around the business workplace, if you will. So if you think about a person being a customer, a person being an employee, or a person being a manager, all of those types of people are a type of person. And when we create an instance of those, in other words, we have Bill, myself, I am an employee. An employee is a type of person, and Bill, himself, is actually the object that we're referring to. And Bill is a type of a person in that case, where a person would be the definition of what the object is, being the person class. So when we have that, we know what we know in our minds, we just automatically get this, that Bill is a person, but a computer really doesn't have that mechanism. It has to have some kind of an understanding of what a person is. It has to be told all the details of what that person is. And that pattern that we use to describe that person is what we call the class. And we do this in code relatively easily by simply creating a class based on the class statement. So a class statement is basically a mechanism that tells C# or any code that we're using what the definition of the object looks like, where it begins, where it ends, and whatnot. In addition to where it begins and ends, it also has other types of functionality inside it. And the first one is what happens when we actually construct a new version of this object. Something that we call the constructor gets called. And the constructor is basically a very simple method that allows this object to set itself up whenever it needs to. So when we think about a color, if I have a class that defines a color, well, there has to be something that actually sets the initial value of what that color is. So if I say color white, we have to have something that defines that the red, green, and blue components are all 255, for example. Now, when we talk about those red, green, and blue color components, we actually are talking about what we call properties. Properties are values or variables that object contains that are stored within it that help define what it is. For example, when I have the person class, the person is probably going to have a name. That name is an attribute of that person and therefore is a property of that person. And we can define properties within our code using a property statement. Another bit of functionality that you might have with a person is that they might have the ability to speak or to listen or to eat or whatever. And those are sets of functionality that are associated with that person. And in those instances, that type of interaction is in code usually done through methods or functions or events. And a class can actually define what those methods, events, and functions actually are. So let's go ahead and start off our day by building a very quick, simple little class and showing how we can actually first create an instance of an object based on that class. And then later on we'll get a lot more complex as we go through here. So as I go to my next slide, what we're going to do is move out to my view sharing demo. My computer screen is set to 1024 by 768, so if your screen is set to that or larger, you can press the F5 key on your keyboard, and that will maximize your display so you can see my entire screen. And when we're done with the view sharing demo, you can press the F5 key again to return back to the normal live meeting console. And as always, there is a questions and answer panel in your live meeting console, so you can go ahead and type in your question in there, and I will actually see these questions on my console as well, and I'll answer them verbally when I come back out of each one of the view sharing demos. So over to my desktop here, I've created a very simple empty Windows form application in C#. There's nothing on here at all. We're just going to go ahead and start off by creating a new class. And there's a couple of different ways of doing it. The easiest way to do that is to simply right mouse click on your project and choose Add Class. And what that'll do is it'll bring up a template builder for us that allows us to choose the Class 1 template. And let's just call this a person class. So by creating a person class, what it's done is it's automatically wrapped it in our application solutions namespace. And it's defined the actual object called person. Now, this is all we need to have a class. So I can actually save this application and build this. So we'll build that, and now from our code we can start using this person. Now, this person doesn't have any functionality per se just yet, but it does give us the ability to create an instance of it. So let's go ahead and create a new person. We'll call this, here's our person class. We'll call this Bill as a new person. So I now have this object called Bill that is a person object, and we can see Bill dot actually has the 4 basic methods that all objects from the system.object namespace inherit. So I can do something like a system.windows. Actually, let's make it even easier. This.text equals bill.toString. And when I run the application, it's just going to change the title window of the application to the type of object that this is, which is any object within the .NET framework is based off of system.object. If they don't override what the toString method does, the toString method just simply returns the type of object that it is. And here you can see that it is a Windows Forms application 1.person type object or class. So we have our very simple class called person. And I can now go through here and set up some very simple objects on it. So let's set up a couple of variables in here. The first one being something that every person has, and that's probably a name. So we'll define a string called name. And we'll define a string called, well, let's do age. And in fact, I have it as an string. Let's make it an integer called age. So now that I have my name and age, I can go back over to my form, and I can actually do things like Bill dot, actually if I have to recompile this here, let me do that real quick. So Bill dot, the right keyboard keys. You know what I did? That actually was right. I forgot to say, in C# when we define a class, whenever we define an object and we add any properties to it, they're hidden by default. In other words, they're marked by private. So I actually need to say that these are public so that other objects can see those values. So there's the public values that I need in front of it. And now when I type in Bill, I get my name and my age. So let's do William Steele. And now when we do this, I can simply say Bill.name, so we can assign the text property of the form equal to the bill's name property of our object. So now when I run this, I get William Steele as the property, as the form name up here. So that shows you how we can actually assign values. And again, just like we did before, we had the age. We can set this equal to 42. So and everything. So life, my age is the answer to life, the universe, and everything. Okay, so that shows you that you can actually set properties on them. And technically, these are very simple values where we actually have a single variable associated with these properties, if you will. And we can actually publicly expose them if we don't want somebody to see it. So let's say, for example, we want something that's private. We can actually mark it as private. So I might have a date time called, date of birth, something like that. So in this case, I have this date time value indicating my date of birth, but nobody can see that, even to create an instance of this class. Later on, we can actually see how the date of birth property can be set and used internally inside of C#. So we'll take a look at that in an upcoming demo. But before then, let's go ahead and talk about those properties. Now, you saw the properties that I assigned there. They were very simple variables. However, there is a little bit more complex scenario where sometimes maybe what you want to do is you want to take a property and look at it before it is written, or process it when it is requested, so it's dynamically generated, for example, instead of a property that is set into a single variable. So there might be scenarios where you have a more complex interaction with the property than what you would normally get with a simple variable like we were just using. So it turns out that classes have a mechanism called properties, which is a statement, that allows us to create a set of wrapper code, in other words, a getter and a setter, a get statement and set statements, that allow us to actually process the data either when we're reading it or when we're writing it, or alternately, turn on and off those features. So what this allows us to do is it allows us to have more complex interactions with our data. So let me go ahead and show you what we can do with a property back in our code over here. So in this case, I have this public property or public variable called age. I'm just going to go ahead and comment this guy out. Actually, we'll just leave it on and we'll do another one. So we'll just say property. Get my code working right here. There we go. When I type in the property, if I just type in the keyword prop, P-R-O-P, and hit tab, it will automatically expand it out into this fully qualified property here. And I'm going to actually change the name from my property to calc age instead of, we have the age variable here, but this one here, though, notice that we have this get and set objects here. Now what these allow us to do is these allow us to actually get and set our ages individually. So here we have, let me just go ahead and set this out this way so we can see this. We can do a get statement, a set statement. And in our getter and setter, what we can actually do is we can say get return age. We'll just do it simple in that RETURN. So we return age. And in this one we can say age equals value. This value is actually what's passed into this when somebody sets this. Now by setting a property, in this case getting, we're just going to return this public property called age already, and by setting it we're actually going to assign it. Now in this particular case we're just reading and writing this variable, but what we really want to do is we want to take this date of birth and use it to calculate our current age. So we'll have to be able to set this at some point. Actually, let's make that public so that we can set the date of birth. And then we can use the calculated age, which will be calculated based on the current date and the date of birth. So in this case, if I save this and go back over to our code, you'll see that I have a method called calcAge, okay, and that's going to actually return a value very similar to the way that the age property would before. In fact, it actually returns an integer, just like as I'm hovering over it, you can see that. So it's actually going to return an integer, and now all I have to do is supply the business logic. So what I can actually do is say, okay, well, let's create a date time now function. So we're going to take now minus the date of birth, and what that's going to do is that's going to return so this will actually return. We can actually take two different types of values and calculate them together. Now, in this case, this is the logic that we're using, kind of the pseudocode. In reality, we actually have to use a mechanism called a time span that will actually calculate those. But I could say, for example, let's make this a little bit simpler for demo purposes. Let's just say the date of birth was 1968, and let's say this is today's date, so 2011. So in this case, I'm going to take the date of birth, I'm looking at date of birth, equals 1968 bill. So 1968, 2011 minus 1968, in this case, is going to return the age. So this is a very simple version of it, but you can see how this is going to work. So in this case, I have the calcAge that I can actually assign, and we can actually, let's make that the date of birth. So if we assign calculate age, it's going to set up the date of birth so we can change that. And if we ask for the value back, it's always going to automatically calculate that value. So let's go ahead and go back over to our code and see how that works. So in this case, we'll do bill.calcAge equals 1968. So in this case, I'm assigning that value, which I actually don't need to do here. And then over here, I'm going to ask for the value back, like that. Actually, it's a property, toString. So here, I'm actually asking for the value back of my age. So I'm assigning it my year of birth, but it's going to return the value of my actual age, which is 40. Actually, it's 42, but in our case, since I haven't had my birthday yet this year, it's showing it incorrectly slightly. So that would be my last birthday. This should be your year of your last birthday. So now it'll give my right age, 42. So in this case, you can see what I've done is I've actually intercepted the actual returning of a property, and as opposed to a fixed property here. In this case, I'm actually doing some dynamic generation of what that property result is, simply by using this getter and setter independently. So in this case, this age would look just identical to this, except that it would have a getter and setter that are simply returning the value as opposed to doing any type of calculation or any other property set on it. So that gives you an idea of how that actually will work. So the property can be used in a much more sophisticated manner than a simple value type or a simple variable like we're exposing through here. Also notice that we still have the public method, the public accessor on this, so that this lets everybody know that anybody that's created an instance of this person can actually use this public variable here. Okay, back over in our code, in our slide deck here. Now that we have these objects, we can actually create much more complex, or now that we have a way to define an object, we can create much more complex scenario with code. Objects are what we use in C# and in fact in the .NET world to basically describe everything that we have in our code. And as a matter of fact, everything in the universe is described as an object of some sort. So, for example, myself, the Earth itself, the computer I'm using, everything that we have is an object. And it turns out that everything that we do in software is also an object. So the classes that we've just seen help us define what those objects are, but the objects themselves are what we actually use to interact with. The objects themselves are what we use to actually store the data or to process the data or to have mechanisms that allow us to utilize those objects. So how do we interact with those objects is based on, it's based off of a definition, but the actual object is what we have to interact with. So for example, I can have a class called a cat and I can have a class called an animal. One is a type of physical object, and one is an abstract concept of an object. So the person object that I used before, you're not going to walk out on the street and find a person. You're going to walk out on the street and find an individual who actually is a type of person. So you can't have an instance of an abstract object, but you can have an instance of a real object like the cat. Even though the cat is an animal, the interesting thing about C# is that you can actually have these abstract definitions like the person, and then when you move later on in your code, you can get more sophisticated and say, okay, this is an employee, which is a type of person. This is a customer, which is a type of person. And they share attributes, both of the they both share the attributes of a person, but they also have their own unique elements that make them different from a person. For example, the employee might have an employee ID number, or might have an email address associated with the work. A customer might have an order, a customer number, for example. So those are some of the things that we would do with an object. Now, when we create an object, there's a couple different things that we can do as we're building an object. You saw me create an instance of the person class earlier, but it turns out that in the construction of that person class, I can also predefine sets of functionality that occur when I set up that object. So, for example, when I have if you have a baby, when the baby is born into the world, it doesn't have a name. It is a baby, which is a type of person, but the general attributes that a person would have, for example, the name, don't necessarily apply because the name hasn't been assigned yet. So it would be nice if the baby was born into this world ahead of time with a name already associated with it. So what if we thought about during the pregnancy that hey, this is going to be the baby's name, and you could make it official before the baby is born. So that's just what we're doing with these constructors. In a constructor, you can actually define a constructor that says, okay, we have a baby, and then after the baby is born, you can assign a property the name, like I did in my person object. Or during the time of construction, I can assign the name, and that when the object gets created, right as that object is created, it automatically has that property called name already predefined for us. It's already set ahead of time. These are what we call parameters on optional constructors. So here I have, on this slide, I have the first type where we create the object itself, and then that allows us to set the properties later, but some objects actually require startup parameters to be initialized ahead of time. And in those cases, we can actually define what we call optional constructor that will take in an additional set of parameters that we can pass into the object to pre-assign them and allow them to be used in a way that is required, if you will, or predefined, more explicit, so that these properties are set and able to be used immediately once the object is instantiated without us having to go and set up the object, so it can automatically be set up. Now, taking this a little bit step further, we can actually say, okay, now that we have these properties set up and we have this initial constructors and definitions of everything in, we also need to be able to actually utilize these objects. And how do we utilize them in a more code-friendly environment? So what I mean by that is, how do we actually get this object to do things for us? For example, a calculator object will be worthless if it can't do any calculations. So we can create a calculator object and we can set some properties like value 1 and value 2. But there has to be some kind of operations that calculator object can perform, like adding and subtracting. And those operations are what we call methods. Those methods can show up in a couple of different ways. One, the method can simply blindly do what you tell it to do. It can set internal properties, or it can actually return the result of those operations to you immediately through what we call a function. The function lets you execute code and have the results immediately. The method allows you to execute code, but the results can be delayed. Now, one interesting aspect of this that isn't on the slide here is that there's another type of interaction that these objects can provide, and that's what's called an event or a delegate. Now, what will happen in those is that a method can be called, and then later on when the object is done doing its processing work or whatever, it can actually notify the caller that, hey, I've completed that task. So it's kind of a disconnected or an asynchronous kind of connection where you say, I would like you to do something, it runs off and does it, and when it's done it calls you back and says, hey, I'm done. That's what we call a delegate. And that's actually another mechanism that we can use to communicate with objects. So let's go ahead and go back into our code, and let's make this a little bit more complex. And in this time, what we're going to do is we're going to take our object, we're going to add a lot more complexity to it, and as well as allow us to set up some predefined functionality in the constructor, and then lastly, go ahead and add some methods and functions that allow it to do work on our behalf for us. So back over to our demoing machine here. Now I have my person class, and my person class actually has some very simple things. It has a property that allows us to do some interceptions of the retrieval of the value, so it can calculate what our actual age is. It also has a couple public variables that are stored in here, as well as maybe even some private ones. In fact, I can mark this one as private, and that would be just fine to this. So let's go ahead and go back over to our code, and let's make it so that we can automatically set up what our name and our age are when we first construct this image or this object. So we're going to do that by actually looking at something that you don't see on here, and that's what's called the constructor. In C#, the way the constructor is done is it's actually a public object called person. Now, interestingly enough, we don't have any parameters, or we don't have anything inside here. We don't even have what kind of a type it is. So normally in C# you would see some additional functionality on this line or additional text. But in the constructor, basically what you're saying is whenever somebody creates a public or an instance of this, this name has to match this name here. This is the name of the class, and this is the name of the constructor, which matches the class. This code will automatically get constructed or executed. So any code that I put in this block here will get executed whenever some new instance of this object is created. So I can actually add other properties in it. Let's say, for example, let's set the default age to 99. So if I don't set the age property, when we construct this, the default age is going to be equal to 99. So let me go ahead and comment the 42 out here, and let's do let's just print out the age. So in this case, I'm creating a new person, but I'm not assigning it the age. As a matter of fact, I can even comment that one out. And when I run this code, you'll see that we get back the value 99 because it defaulted the value to 99 because in my constructor I said, okay, whenever I create an object, go ahead and execute this code as a part of creating that object, and then we can assign that. Now what I can also do is say, okay, well, I'd like to actually have another instance of the constructor that says, okay, maybe you might optionally pass in the age. So what I can do is I can create another instance of this, and I can pass in the default age. Do that, call it default age. And in this case, what I've done is I've created another copy of this person method, only this time it has a parameter that I can pass in optionally that will set that age for me. So this is the default constructor, and this is the overloaded constructor. So now in my code, I can see here that I have, when I create this person bill, when we execute this, just the same as before, we got the value 99. But if I go ahead and look at the signature here, you'll notice that in Visual Studio, it's done something really nice for me. It tells us that there are one of two constructors for this person method. And the first one takes no parameters, but when I scroll down to the second one, I get a default age as the second parameter. So I can assign any integer that I want to here. So I can make this 42. And without assigning it here, I'm actually assigning it in the constructor. Now when I run the code, I get the value 42 as my text box title, or my Windows form title. So that actually is a way we can set that. Now, one other interesting thing that I can do here is I can actually take this a step further and say, well, let's have several different constructors. Instead of having just one, let's do a string for the name. And let's do another one. Let's make it double. Let's have multiple signatures. So here I have, let's take the default name, assign that to the name property. Let's take both of those. So we have the default name and the default age. So in this case, I have multiple constructors. The first one will simply assign the name if we pass it. The second one will simply assign the age if we pass it. The third one actually takes both the default name and the default age and assigns them both. So that makes this a lot more complex. When I go back over to my code, now when I look at my options, I can see that there are 4 different constructors for it, and each one has their parameters. And I can actually choose which one I want. So let's do this one, William Steele, and 42 is the age. So let's comment that one out, and let's just do name. So here I'm actually having it display the name, and the constructor is actually what's assigning the name. So my window will be called William Steele in this case. Now that's kind of cool. That allows us to actually set up some additional functionality that's required before our object is used. But what about after our object is used? Just like before where we calculated the age, maybe there's some functionality in here where we wanted to actually assign more complex objects or do some more complex interactions. One of the things that we might want to do is to be able to have not just a name, but to be able to parse this out and maybe into a first name and a last name. So I can do this in a couple different ways. I can actually have a property called name, and the name might be the full qualified name, first name plus last name. And then I might have some additional properties for just the first name and just the last name. So we can actually do that. We can set up a public property. Let's do a string, and we'll call this first name. And then we'll do another one, public string last name. And then on this, instead of doing the name like we did here, we might have a method that we call that actually puts this together for us. So let's do a simple function. So we might have something like public void make name. And in this case, we'll say name equals first name plus space last name. So in this case, what we're doing is we're telling C#, okay, go ahead and take the first name and the last name and concatenate them together and create this new third object called, the full name here. We could call that full name. Actually, we'll just leave it as name. So now, instead of me calling the constructor to do this, let's just comment that out. Let's go to bill.firstname, William, and bill.lastname, Steele, and bill.makeName. We're just calling the method makeName, which is actually going to perform the business logic to take William and Steele and add them together. Let's make that bill so it's a different one. And then we'll display the bill name here. So when we run this code, I get the text value bill Steele. And what's happened is it's actually, by executing this code here, this method call that returns no value, it went ahead and processed all that. And I can do the same thing here, returning a value. Let's call this full name. And actually we'll return a string. And instead of copy that, and we'll just say return that. So now what I have is a new function. This is a function because it's returning a value called full name, and the full name is the concatenation of the first name and the last name. So again, back over in my code, I can actually say, we don't even have to execute this one. We can simply say bill.fullname run this code, and now I'll get Bill Steele as the result as a full name. So assigning these individually, and now I have a function that actually returns that. So here in this case, what you can see is some interesting interactions. What we wind up with is a function. We might have many of these. We might have functions that do some particular operations on this, maybe changing the case of the letters, making them all capital case or camel case or however we wanted it, or processing business logic, taking data in. Maybe I might have an additional version of this function. This is actually an interesting thing. I can have multiple overloads, just like we had overloaded constructors. I can pass in a middle name here. Let's do this and that and say. So in this case, I've got a full name that will take a middle name as a parameter and give us the full first, middle, and last. Again, just like we did before, I can do something like this. And we have two constructors. So this one would be J, like that. And now when I run this code, I get Bill J. Steele. Well, actually, technically, that's not my name. William J. Steele. So there I get William J. Steele. And what it's done is it's actually called the second one based on matching that it needed the parameter. And I've added two additional properties in this new string that I passed in as a parameter to get the full name value back. So you can see here that these objects can actually be very complex. In this case, it's a simple person. A person can actually be, more complex than what we see here. In fact, when we get into object-oriented programming, we're going to see that we have the ability to take this person and make a more complex object out of it. As a matter of fact, I can do that right now very simply. I can simply say something like class employee, which inherits from person, like that. And then what we get here is actually, I'm trying to remember what correct syntax on this one is. But I have an employee class that actually inherits from this person, is a type of this person here. And what happens is this employee will actually be of this type person, which is a type that is, there we go. So this employee is of a type person, and if I created a new employee, it's going to inherit all of these methods and properties that we had of the other one. But it might even have some additional ones on top of that. So maybe it has a property called employee ID. And now when we go back over to our person object, we can actually say, well, instead of Bill being a person, in this case he's an employee. And inside here you'll see that we have Bill dot, I have all of those other features, the age, the calculate age, the first name, last name, and all that. But I also have the employee ID property, which isn't a part of the person. So this actually lets us see that we can have a hierarchy of objects where one is more complex abstraction of the other one, and they get more and more complex until eventually you wind up with an object that is actually the real McCoy. It is the real actual object that has all of the definition of all of the objects, contains all the functionality and methods and functions of everything that was developed before that. So hopefully this helps you see how classes and objects in C# work, how we can actually construct them, how we can utilize the various properties and the functionality to methods and functions to add to these objects to make them an object that can stand on its own, deal with the particular aspects of what that business logic should do. So in this case, a person, what kinds of properties a person should have, what kinds of functionality a person should have. The class itself is the definition of what all of this functionality is, and the object is the actual construction of that class from the blueprint that is the class. And then the ability to use that by calling, setting the properties, setting the parameters on the constructor, as well as executing any of the business logic functionality that's associated with each one of those sets of code. Okay, so back over to our slide deck. Short session today, we covered the definition of what a class is. We saw how we created a class using the class statement. We then set about to define some properties on that class, as well as some of the interaction with methods and functions. Remember, the only difference between a method and a function is the method doesn't return a value, where a function does return a value. And then lastly, we converted those classes into actual real objects. So we took our person class and defined a person out of it. Saw how you create the object using the constructor, as well as how you can pre-initialize that object with constructor parameters using what we call the overloaded constructors. And then again, how we can use those objects and how we can actually create one object derived from the other object that allows us to have a more complex version of the object, or actually how we have a hierarchy. And it turns out that inheritance model that you saw there, I didn't use the word inheritance, but the person, the employee is a person, and Bill is an employee. That's the entire model that the .NET framework uses. So everything is derived from system.object, and then there are more complex versions of the object beyond that. So the button that you saw on the screen, or the window that you saw on the screen, is a type of object, just the same way as an employee is a type of person, and then that person is a type of object. So we see how we can see how that hierarchy helps us naturally evolve up into more and more complex, or more and more task-specific types of functionality. And that's what a class and object structure allow us to do. So next week we're actually going to talk about operators, and we're going to see what kinds of different types of operators that C# allows us to utilize. We're going to see how we can actually use those in our code to do some specific sets of functionality that so far we haven't really seen, except for a little bit of minor assignment operators. We're going to see how we can use operators, which are a way of asking C# to do specific tasks for us in a very short and kind of terse way, if you will. So that's next week's episode. Until then, I want to say thank you for stopping out and watching this session on classes and objects. Feel free to ask me any questions via email, wsteele@microsoft.com. Follow me on my on Twitter account at wjsteele. And as always, keep an eye on my blog out there and see if there's any updates and code functionality, things like that. Don't sign up just yet. I'm going to ask Sydney to take you back over into the slide. The survey slide where we'd like to get your feedback on this session and all the other sessions that we do, and what kind of webcast that you'd like us to start CS putting on. I'll be happy to. I read pretty much all of these whenever we can, and we get this feedback. We utilize it to help us formulate what we're doing in our next webcast series. So Sydney, back to you.
Thank you. I'd like to remind everyone that you can print a PDF of the slides by clicking on the printer icon in the lower right corner of your screen. You can either print or save those slides locally for your convenience. You should all be seeing a survey now in your slide area. If you could take a moment to fill it out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow one of the 3 links provided to complete the evaluation. And with that, I'd like to extend a special thanks to Bill for today's presentation. Thank you all for joining us. You may now disconnect from the audio portion of today's conference.